Hey there, and welcome to another video by Adeptis Academy. Today, we're diving into the fascinating world of thermodynamics. Thermodynamics is like the ultimate energy accountant. It's the science of how energy, especially heat, behaves. Think of it as the rule book for how energy transforms and moves. It's everywhere. From the engine in your car to the refrigerator keeping your snacks cool, thermodynamics is the silent force at work. Get ready to unlock the secrets of this fundamental science and discover its incredible impact on engineering and technology. Let's start with the first law of thermodynamics, which basically says you can't create or destroy energy, only transform it. It's like the ultimate cosmic rule. Imagine a game of energy billiards. You can hit the balls, transferring energy from one to another, but you can't make new balls appear or disappear. This law is crucial for engineers because it means they have to carefully account for all the energy going in and out of a system. No energy is ever truly lost, just converted into different forms. Now let's talk about the second law, which introduces the concept of entropy. Entropy is a measure of disorder or randomness in a system. The second law states that entropy always increases in an isolated system. Think about it. It's easier to mess up a perfectly ordered room than to spontaneously clean it up. This law has profound implications for energy efficiency. It means that every time we convert energy, some of it will inevitably be lost as unusable heat, increasing the overall entropy of the universe. Thermodynamics is the backbone of countless technologies we rely on every day. Let's take a look at some examples. Engines, like those in cars and airplanes, are essentially sophisticated heat machines. They convert heat energy from burning fuel into mechanical work, propelling us forward. Refrigerators, on the other hand, work by transferring heat from a cold interior to the warmer surroundings. They defy the natural flow of heat, thanks to clever thermodynamic principles. Thermodynamics isn't just about explaining existing technologies, it's also a driving force behind innovation. Engineers are constantly pushing the boundaries of energy efficiency, guided by thermodynamic principles. They're developing new materials and designs to minimize energy waste in everything from power plants to smartphones. Renewable energy technologies like solar panels and wind turbines also rely heavily on thermodynamics. They harness natural energy sources and convert them into usable forms, paving the way for a sustainable future. Mechanics, the study of motion and forces, and thermodynamics might seem like separate fields, but they're deeply intertwined. The principles of mechanics govern how objects move and interact under various forces, while thermodynamics deals with the energy transformations that accompany these movements. When we delve into the world of mechanical systems, we find that heat and motion are inseparable companions. Every mechanical system, from a simple lever, which is one of the most basic machines known to humanity, to more complex systems, involves some form of energy transfer. When a lever is used to lift a weight, for instance, the effort applied is converted into mechanical work. This process, though seemingly straightforward, generates heat due to the friction between the lever and its pivot point. As we move to more advanced mechanical systems, such as industrial robots, the interplay between mechanics and thermodynamics becomes even more pronounced. These robots, with their intricate networks of gears, motors, and sensors, generate significant amounts of heat during operation. The friction between moving parts, the electrical resistance in circuits, and the energy losses in motors all contribute to this heat generation. This heat can affect the system's performance and longevity, so engineers need to account for it in their designs. Overheating can lead to the degradation of materials, reduced efficiency, and even catastrophic failures. Therefore, thermal management becomes a critical aspect of mechanical design. Engineers use thermal cameras and other diagnostic tools to monitor and manage the heat generated in these systems. Understanding the thermodynamic properties of materials is also crucial for mechanical engineers. Different materials respond to heat in various ways, and selecting the right material for a specific application can make a significant difference in the performance and durability of a mechanical system. Engineers conduct rigorous tests to determine how materials behave under different thermal conditions. Different materials expand and contract at different rates when heated or cooled, a phenomenon known as thermal expansion. This property can have profound implications for the design and functionality of machines. For instance, if two materials with different expansion rates are used together, the resulting stress can cause parts to warp or fail. which can impact the functionality of machines. Engineers must carefully consider these factors when designing mechanical systems to ensure that they operate reliably under varying thermal conditions. By understanding and managing the relationship between mechanics and thermodynamics, engineers can create more efficient, durable, and reliable machines. Robotics is another exciting field where thermodynamics plays a vital role. The integration of thermodynamics into robotics is not just a theoretical exercise. It has practical, real-world applications that are transforming the way robots are designed and operated. From the materials used to the energy systems that power them, thermodynamics is at the heart of robotic innovation. Robots, especially those designed for extreme environments, need to manage heat effectively to function reliably. This is crucial because excessive heat can damage sensitive electronic components and reduce the robot's operational lifespan. Effective thermal management ensures that robots can perform their tasks without interruption, even in the harshest conditions. Imagine a robot exploring a volcano. The intense heat and unpredictable environment present significant challenges. These robots must be equipped with advanced cooling systems and heat-resistant materials to survive and operate efficiently in such extreme conditions. It needs to withstand intense heat without its electronics overheating. This requires a deep understanding of thermodynamic principles to design systems that can dissipate heat effectively. Engineers must consider factors such as heat transfer, thermal conductivity, and the specific heat capacity of materials. Engineers use thermodynamic principles to design cooling systems and choose materials that can handle the extreme conditions. They employ innovative techniques such as phase change materials, heat pipes, and advanced insulation to ensure that the robots remain operational. Thermodynamics also comes into play when designing robots for energy efficiency. By optimizing energy use, robots can perform more tasks without needing frequent recharges, making them more effective and sustainable. The longer a robot can operate on a single charge, the more it can achieve. This is particularly important for robots used in remote or hazardous environments where recharging or replacing batteries is not feasible. By improving energy efficiency, we can extend the operational range and capabilities of these robots, making them invaluable tools in various industries. As we've explored, thermodynamics is more than just a branch of physics. It's the unsung hero of modern engineering and technology. It forms the backbone of countless innovations and advancements that shape our daily lives. From the cars we drive, which rely on the principles of thermodynamics to convert fuel into motion efficiently, to the smartphones in our pockets, where thermodynamics plays a crucial role in managing heat and ensuring optimal performance, countless technologies owe their existence to the principles of thermodynamics. Whether it's the cooling systems in our computers or the energy-efficient appliances in our homes, thermodynamics is at the heart of it all. As we continue to innovate and push the boundaries of what's possible, the role of thermodynamics becomes even more significant. Researchers and engineers are constantly exploring new ways to harness and optimize energy, making our world more sustainable and efficient. Understanding this fundamental science will be more critical than ever. Educational institutions are emphasizing the importance of thermodynamics in their curricula, preparing the next generation of engineers and scientists to tackle the challenges of tomorrow. So the next time you encounter a machine, whether it's a simple household appliance or a complex industrial robot, take a moment to appreciate the invisible hand of thermodynamics at work. It's the silent force driving progress and innovation, making our modern world possible.